Hello students, we have previous class studied about our fourth chapter magnetism. So we have studied previous class our fourth chapter magnetism part 1. Today we are discussing our part 2. So there we have studied magnetic field lines. What is magnetic field? Magnetic field means around a magnet experience force. Around a magnet experience force. No, that force is called a magnetic field. Around a magnet experience a magnetic field lines. That is called a magnetic fields. So today we are discussing about magnetic flux density. Magnetic flux density. What is magnetic flux density? You know that what is density. You have studied in your first chapter, measurement and unit. What is density? It is a new concept for you, but you know that density. How you calculate density? Mass divided by volume. That is a formula of density. So we are finding the density mass divided by volume. So what is magnetic flux density? See here, for that understanding purpose, what is magnetic flux density? That understanding purpose we are explained by experiment. That time you clearly understanding. See there, take one like that, tie a bar magnet. It have two poles, north and south pole. So bring near a needle, magnetic needle, bring near to this bar magnet. So what happen? You should bring near around this bar magnet, means there magnetic needle deflection takes place. Why magnetic needle deflection takes place? Because around the bar magnet experience a magnetic force, so that a magnetic needle deflects around the magnet. So this is due understanding. In a magnet, around a magnet experience a magnetic force. That force is called a magnetic field. So what is magnetic flux density? The number of lines passes normally to a unit area. The number of magnetic field lines passes normally to a through unit area. That is called a magnetic flux density. So here, what is magnetic flux density? The number of magnetic field lines passes through normally to a unit area. In particular area, how many numbers of magnetic field lines are passing? That is called a magnetic flux density. You have studied in your first part. The like poles are repels each other, unlike poles are attract each other. So if two poles, north and south pole, like that, this is north pole, this is also north pole. These two poles called like poles. This like poles repulsion takes place, does not attracting. So the magnetic field lines, how experienced around here? So the magnetic field lines moving, bending like that. Magnetic field lines bending sideways direction. Magnetic field lines are bending in this direction. So you have studied the unlike poles are attract to each other, no? So how the magnetic field lines experienced around that? This is a south pole, this is a north pole. So their attraction, so the magnetic field lines are experiences like that here. The magnetic field line is moving from north pole to south pole. So this, like this pattern, the magnetic field lines experience. In a bar magnet, how magnetic field lines are experienced, it is an imaginary line, no? So like that experienced. Same process in between like poles, the magnetic fields experience like that. In a unlike poles, between unlike poles, the magnetic field lines experience like that. So what is the peculiarities of that magnetic field lines? These magnetic field lines does not coincide one another, no? These does not coinciding here. They separately dividing. Another, in a like poles, the magnetic field lines are bending in sideway direction. In unlike poles, the magnetic field lines moving south pole to north pole to south pole. Magnetic field lines moving from north pole to south pole. So this was studied here. So this is the peculiarities of a magnetic field experienced in between like poles and in between unlike poles. Magnetic field experienced all dimension around a magnet. Here around a magnet force is experiencing. Now all dimension around a magnet experienced magnetic force. So that you understood from here. So you know that the some metals attract the magnet, which all nickel, cobalt, iron. These all metals attracted magnets. Next we are discussing about magnetic induction. What is magnetic induction? So there is one experiment is there. See here, you should tie a bar magnet like that. There is two poles, south pole and north pole. We should take some iron nails. So you should bring one nail to near to the bar magnet so that attraction takes place. No? Take another one bar magnet near to this, and so this also attraction. So till this some bar magnets are attracting here. Nearly here 5 iron nails are attracting. So afterwards this not attracting because that loses the final pin loses the magnetic power. So that does not attracting. So this process their attraction takes place. Nearly 5 pins are attracting. So this pole is converted as north pole. What is this? And you know that unlike poles are attracting, like poles are repelling. So they are here attracting. So this pole is converted as a south pole. Then this tip is converted as a north pole. This converted as south. This north pole, south, north, south. Like that continually changes the poles here. Next, is it if you remove this bar magnet, you should hold this first iron nail and remove this bar magnet. Is it attraction this iron nail? You can see shape pattern. No, these iron nails falling down. Why? That loses the magnetic power. So these iron nails falls down. So when they are attracting in the presence of magnet, they are attracting. This is the phenomenon, a magnetic substance acquiring a magnetism due to the presence of a magnetic field. Due to the presence of magnetic field or in the presence of magnets, it is called a magnetic induction. Magnetic induction is the property a magnet substance acquiring magnetism due to the presence of magnets. It is acquiring a magnetic power due to the presence of a magnet. This is called a magnetic induction. So see here, you should take here like that, suspend a bar magnet. There is two poles. Then here attract one pin, another pin it attract like that. So this tip of the pin is repelling. Why that repulsion takes place? Because these two ends are same pole. You are studied the unlike poles are attracting, like poles are repelling. So these two poles also converted as a north pole. It is north converted as south. This also north. So north means there is a unlike poles. The like poles is repelling each other. Next we are discussing magnetic induction in iron and steel. So you should take here also one experiment is there. Take one bar magnet, tie like that. There is two poles. Take two same size iron piece and steel piece. Iron piece is same sized iron piece and steel piece. Bring a small piece of iron near to this magnet. So what happened here? This iron piece bring near to the bar magnet. So their attraction takes place. Then this heap into the free end is heap into a iron nail. So they are attracting nearly 5 iron nail towards here. It is a bar magnet. It is attracted by a small piece of iron. It is a magnet. It is attracted by a iron. So this free end is heap into a iron nail. So there what happened here? 5 iron nails are attracted here. Next, the same arrangement you should bring near here steel. So steel also attracted magnets. So these free end is bring near to the iron nail. So here nearly in a steel 3 pins are attracting. So which is converted as a strong magnet is suddenly converted iron as a magnet. Iron attract 5 numbers of iron nails, but steel attract only 3 numbers of iron nails. So this is explained by the susceptibility and retentivity. What is susceptibility? Susceptibility is the object gets suddenly magnetic power, suddenly attract towards the magnets. Here iron piece have more susceptibility, steel have less susceptibility. So retentivity, which one have more? The steel have more retentivity, that retain as a magnet, then iron have less retentivity. We should see the difference between the iron and steel. What is the difference? See there, the ability to retain magnetism acquire is very low. Which one? Soft iron. The steel, the ability to retain magnetism acquire is very high in a steel. In a soft iron, it is easily subjected to a magnetic induction. In other words, its susceptibility is high. In a steel, it is not easily subjected to a magnetic induction. In other words, susceptibility is very low. The steel susceptibility is very low. The susceptibility of iron is more. The retentivity of iron is less. The steel is more. This is the difference between iron and steel. So here iron is a temporary magnet. Iron is a temporary magnet. The steel is converted as a permanent magnet. Next we are discussing electromagnet. How you convert electromagnet? See here, we should arrange like that. It is an wire. It is connected to a battery. connected to a battery. Insert a nail inside the wire. Here you should insert a nail. When you pass electricity, this nail converted as a magnet. So repeat this experiment. It is called a electromagnet. When you pass here current, this iron nail converted as a magnet. How you understanding that iron nail converted as a magnet? You should bring near here one nail. So it attract this nail. So here this iron converted as a magnet. So this experiment repeated by increasing the number of turns. You should increase the number of turns of this wire coil. Increase the number of turns of the coil, and you should use the strong battery. Otherwise, increase the number of batteries and insert a highly cross section area iron. So here the magnetic power increases this iron piece magnetic power increases by increasing the number of turns of the coil and by increasing the number of batteries and increasing the cross section area of this iron piece. So that time we can increases the magnetic power. This arrangement is called the electromagnet. When you pass electricity through this iron converted as a magnet. So the study, the steel is permanent magnet. Steel is used to make permanent magnets. The iron is an temporary magnet. So today's class we are discussed the topics magnetic induction, electromagnets and magnetic field. So we will continue our next class. We have completed our 4th chapter.